Right here we have a depressed cubic equation. That just simply means that there's no quadratic term, right? There's no x squared term. You have your third degree term, you have your first degree term, and you have your constant. No quadratic term is what makes it depressed. Now, I solved this equation 5 years ago. I have a video, and I did it by making the substitution, let x equal y plus 1. But no one questioned how I knew to make that substitution, so that's what I want to do in this video, is go a little deeper and show you where this substitution even came from. And the irony of it all is it's actually pretty much circular reasoning with a little bit of luck. So what we're about to do is by no means a way to solve any depressed cubic equation. It probably won't work most of the time, but here it does, and it's fascinating. So let me walk you through it. So how I came up with this is I wanted to know, is it possible to make a substitution so that we'll end up with a polynomial that's factorable by grouping? Because this right here, this is not factorable by, well, the only way we'd factor this is guessing and checking. I wanted something that was a little more, concrete, certain, and I like factor by grouping. So we're gonna let x equal y plus a, and we're gonna pretend like we don't know that a is gonna be 1. So let's pretend like we don't know that, and see what happens. So I'm gonna go ahead and substitute in y plus a. And let's go ahead and expand. So here's a little binomial expansion here. Y cubed plus 3 y squared a plus 3 ya squared plus a cubed. And then distribute that minus 6 there. We'll have negative 6y. Whoa, where'd my a cubed go? That's a cubed minus 6y minus 6a minus 4. Good. Now let's get a little organized here. Y cubed is the only cubic term. 3a y squared, I just rearranged that a little bit. Because the variable here, we're going to treat y squared as the variable. And let's see, we have two linear terms, the 3ya squared minus 6y. So I'm going to go ahead and pull those together and group up the constants. So 3a squared minus 6, I should have said coefficients, group up the coefficients here. And then the remainder of our terms are all constant terms, or we're going to treat them as such. A cubed minus 6a minus 4 equals 0. So good. Okay, this would be the resulting polynomial after we make that substitution. And I want this polynomial to be factorable by grouping. So let's go ahead and take that route here. So out of these first two terms, actually I want to put my blue bar right here. Cool. Out of these first two terms, I can factor out a y squared, so we're going to pull out a y squared, leaving behind y plus 3a. Now, to make this work, I'm going to need to factor out the 3a squared minus 6. So that's 3. Oh, let's not put a plus sign here. Okay. 3a squared minus 6. And that's going to leave behind y plus. Now, remember, when you're pulling out numbers, when you're factoring out quantities, that's division, right? So I need to divide this by that. That is what's going to be left behind, and that will be a cubed minus 6a minus 4 over 3a squared minus 6 equals 0. Okay, good. Now, in order for this to work, this needs to be the same as that. Those two values need to match. Otherwise, the factor by grouping will not work. So, if you need to pause and think about that for a minute, I'll let you. But I'm going to move forward here. We want, right, or we need 3a to equal a cubed minus 6a minus 4 over 3a squared minus 6. All right, again, those are these values right here, that and that. If those match, the polynomial will be factorable by grouping. Oh, I'm not going to put equals 0 anymore because we're kind of on a tangent now, right? So multiply both sides by the denominator. distribute kind of fascinating how the original depressed cubic is still here. But now we're going to go ahead and put everything on the left side. That'll give us 8a cubed minus 12a plus 4 equals 0. And then if we divide everything by 4, 2a cubed minus 3a plus 1 equals 0. Okay, great. So if we could solve this for a, then we will know what to put in for this a up here. However, the irony in all this is to solve this depressed cubic equation, we need to solve this depressed cubic equation, right? So it feels like circular reasoning. I mean, well, it really is circular reasoning. So how could we solve this? Do we try to make another substitution and run the whole process again? Take this like Inception, take it another layer deeper? I don't know. I actually haven't tried that. Now I'm curious, but here's where we get lucky, is if you look at the coefficients, 2 minus 3 plus 1 is 0. So one of the solutions is 1, right? Because 2a minus 3 plus 1 equals 0, we have a solution. A equals 1. Now, there are more solutions than that, but hey, we got a rational solution, a real and rational solution. That's a beautiful thing. So, and again, that was just luck. If you miss that, pause it and think about it. All you have to do is put a 1 there in for A, and it'll work out. So, if we let x equal y plus 1, it should give us a polynomial that's factorable by grouping. So let's go ahead and do it again and make that substitution. So at this point, I'm just repeating what I did in my video 5 years ago, so you're welcome to go watch that. But we'll do it again here. So we have x cubed, back to the original problem, we have x cubed minus 6x minus 4 equals 0. And we just made the discovery that if we let x equal y plus 1, this should work. So let's go ahead and plug that in. Y plus 1 cubed minus 6 times y plus 1 minus 4 equals 0. Expand, we have y cubed plus 3y squared plus 3y plus 1 minus 6y minus 6 minus 4. All right, great. Combine like terms, we have y cubed plus 3y squared minus 3y minus 9. And here we go. Let's see. Can we factor by grouping? So we'll factor out a y squared, leaves behind y plus 3. Pull out a negative 3, right? Whenever there's a negative here, you should pull it out as well. And that'll make the second factor the same. So look, remember way back, right, when I said this quantity has to be the same as this quantity for it to work. Well, look at what we got. We got it, right? There's a 3, there's a 3. They match now, right? They match now. So that's great. Factor by grouping only works when those factors match. We pull out that y plus 3, and that leaves behind y squared minus 3 equals 0. And I'm trusting you're familiar with this. This gives us a solution of y minus 3. And this gives us two solutions of plus or minus root 3. So we do have a couple irrational solutions, but okay, great. It feels like we're actually getting somewhere with this. However, remember, the end goal here is to solve for x. We're not trying to solve for y. So we got to make our substitution back. Remember that we let x equal y plus 1. So our first x is going to be negative 3 plus 1, which is negative 2. And our second and third x, but we'll write them as 1, is going to be plus or minus root 3 plus 1, which can be written as 1 plus or minus root 3, right? So finally, hey, we did it. There we go. Those are the answers right there. Those are the answers to the original equation. So here's the whole thing right there. A little bit of recap. Again, we set out to try to find a value for A so that this polynomial would be factorable by grouping. In order to find that A, we had to solve this depressed cubic equation, which really doesn't put us in a better position than we were at the very beginning, because the beginning problem was also a depressed cubic equation. However, we got lucky because 2 minus 3 plus 1 is 0, revealing to us that 1 is a solution to that depressed cubic equation. So we then made that substitution. It gave us a polynomial that was in fact factorable by grouping. We did that. We got those two solutions. Substitute back to get the final solutions. So you may be asking, we were able to just look at this and figure out that one of the solutions is 1. Hey, maybe if we thought about it a little bit longer, we could have figured out that -2 was a solution to the original if we just thought about it. So, yeah, I mean, the reasoning is the same. It's circular reasoning with a little bit of luck is what I'm teaching you today. So not your typical math lesson. But last thing I want to do is I want to take you over and look at these graphs. So here's the original equation we were trying to solve. And look at, there's our -2 right there. There's our -2 right there. These are the other irrational solutions. But what's kind of cool here is the blue graph is the second depressed cubic equation that we stumbled upon. And you can see here that it crosses at 1. And that's the substitution we were able to make. That 1 led us to the -2. And then, of course, the other irrational solutions. So very good. Very good. Well, thanks for hanging out. I hope you learned something. If you find this interesting, please like and subscribe. All right. Have a good one.